We're going to be talking about the plant and insects, specifically of the Mesozoic. We will start dinosaurs tomorrow, and it will run us through the rest of the week. Actually, no, I just lied to you. Tomorrow we will be doing mammals, lesser reptilians, and birds. And then dinosaurs will take us through the rest of the week. I did go through and read all of your that writing prompt that we did, and I think I managed to get all of your inquiries into the notes on Friday. Now, I thought that the asynchronous day was the 12th, but I was mistaken. It's this Friday. It's where you're at home and you have to do the online stuff, which is the Cretaceous period of dinosaurs is what I have. What I'll do is I'll just record myself and post it. I don't want to do it that way at all, but there's no way I can do the Cretaceous video on that day. I just can't. It's not going to happen. I just, like I said, I was mistaken and had the wrong day for the asynchronous. You guys all get to go be at home. So does my kid across the street. Anyways, today's isn't as beefy as, where's my stupid remote thing? As beefy as Friday's was. Oh, it's still a little lengthy. It's a lot to try to cover. All of the Mesozoic in 7 days total is quite a bit to get through for today, for the opener. Since we are talking about plants and insects, why were the vascular plants, the ones that had moved inland from the Permian, not as heavily affected as the oceans? The oceans saw a 96% decline, and terrestrial animals saw a 76% decline, but the plants didn't fly. That specifically that. Your vascular plants, not the ferns, not the ones that had spores that had to wick the water up through their tissues. Somebody just booped something off the screen. Your vascular plants, your things like ginkgos, which we used to have one in my front yard as a child. I have not counted anybody absent yet. I haven't even checked online attendance yet, Erica. I'm about to do that here in just a second. Your vascular plants pulled their water up through the ground, which was filtered by the earth itself, which conveniently enough, we just went through it. Well, we didn't have a boil notice here, but a lot of people did. When you use those like Brita filters, you're filtering through charcoal. And a lot of that charcoal came from either the Permian or the Mesozoic eras. This is still working. I haven't plugged this thing in forever. We will be talking about the plant recovery and just a little bit of the insect recovery. The plant recovery is more important than anything else because all of the theropods, and the sauropods, the dinosaurs that we're eventually going to talk about were dominant by the end of this particular time period. The Triassic was the reset. Lots of things saw their recovery in this time period, or their evolution in this time period. Turtles are older than dinosaurs. Mammals showed up at the same time as dinosaurs. Everybody thinks that they didn't evolve until after that asteroid slammed into the Yucatan Peninsula 65 million years ago, but that's not true. mammals and dinosaurs actually started evolving at the same time, give or take 230, 220, 230 million years ago, give or take. The Permian extinction happened 251 million years ago. We did not have a true recovery for almost 6 million years.
Are those animals evolved?
I don't even remember. I gotta look. What evolved by the end of the Triassic? Yes, turtles, which are ancient. The thecodonts were eventually dinosaurs, pterosaurs, and birds. Now, your pterosaurs and your plesiosaurs, the pterosaurs were the flying dinosaurs, but they weren't dinosaurs. Your plesiosaurs were your marine dinosaurs, but they weren't dinosaurs. Those two branches are actually older than dinosaurs. Dinosauria was, or your two major branches of dinosaurs were much later. Your crocodilians, your descendants of the archosaurs, are way older than dinosaurs. But yes, mammals are our ancestors, 200 plus million years ago. Our ancestors evolved at the same time. This is not great. Oh, well, it's okay. I'll carry out this for you. The plants, this is the answer to the opener. The plants didn't have as much of a die-off because the water was filtered through the earth itself. Took out the acid rain, didn't have the heavy metal, the mercury, the lead, the horrible chemicals that will make us go insane before it kills us. Didn't have to deal with any of that stuff. Your less advanced plants, things like moss, things like the seedless ferns, they were a little bit more heavily affected in this time period. Your more modern plants had that seed coat. In the Triassic, it was really hot, really arid. They couldn't pull moisture from the air. The seed coat helped prevent the offspring of said plants from drying out or desiccating. Same thing. Your vascular tissue, the xylem and the phloem, which pulled the water up through the earth itself, filtered out said heavy toxins. These two milestones of gymnosperms specifically allowed for the flourishing of the plant life, which allowed for the animals to recover, eventually pumped so much oxygen into the air that allowed these organisms, which eventually became dinosaurs, to become huge. Like, they would step on us and squish us flat, kind of huge. The largest dinosaur's footprint was literally as long as I am tall. Like, it was huge. And titanosaurs didn't develop until the Cretaceous, and we'll get into those. I think that's the one that I have to do remotely from Friday, which I don't want to because some of your favorite dinosaurs will be on Friday's notes. Things like T-Rex, Argentinosaurus, Apatosaurus. They're in that particular section. All right. From the Permian, our massive coal-producing plants, they dried up and they died. And that's one of the reasons why both in Argentina, or not Argentina, I apologize, in Antarctica and in where the, oh my Lord, I have no person on it. Syria, where the tracks happened. The large deposits of coal were from this extinction. They didn't have the moisture that was necessary to keep the plants alive. Eventually they died, everything dried out, and they became the giant coal beds that we have now. The replacement of these eventually became what you think of as a Christmas tree, an evergreen. Conifers, cone seed-bearing plants, were one of the most dominant organisms at this time period. You had very specific localized environments. The interior of the Triassic was very, very, very dry. Along the coast where the Panthalassic Sea touched, you had monsoons. So you had literally swamp, marsh, boggy snot, and then you had completely dry, barren land on the inside. This caused the organisms to be extremely localized. And that was one of the things that actually killed off things from the Permian, was a localized environment. The things that were a little bit more diverse as far as their environment, their locality was concerned, survived. In the Triassic, it sort of put a stop on that. Let me double check. Let me freeze this and double check online real quick because I haven't done online attendance yet. Okay, I see Erica. Sarah. We got Sarah. Let's see, Joseph, Colton, Chase, Braylon. Who am I missing? Alex, Otis, Joseph. Joseph, I see. Don't see Isa, I don't see Caden. Taylor's in person. Jimmy. Okay. If you don't understand the terminology, biota just means like a living organism habitat, if you will, whether animal, plant. We had, when in the Triassic, we had the splitting of Pangaea, and the northern continent was Laurasia, and then the southern continent was Gondwana. The infamous Glossopteris, that fern that was found everywhere on the southern half of Pangaea, was pushed out. It was replaced by Diprodium. It was just the next evolutionary advance that Glossopteris just couldn't compete with, and it went extinct. I have not double checked the movie Jurassic Park, and I know all of you have seen the original, or at least most of you have seen the original. When they're first coming in, before she realizes there's a brontosaurus like walking next to her, she pulls a plant, and I'm not sure which species that was supposed to be. I need to go back and double check it. And no, we're not going to watch Jurassic Park. There's too many things that are wrong, let alone that they base their velociraptor off of the wrong dinosaur. It's not correct. Velociraptors were about yay tall. They were like the size of a turkey. They were not the size of a person. That was completely and totally wrong. But we had other ferns. Like I said, conifer is just what you think of as like an evergreen, like a Christmas tree. Cycads are, I don't know how many of you have been around a sago palm. My neighbor's got two in the front yard. Those have been around since the age of the dinosaurs. It's not a palm tree. It's got fern-like branches. It's also extremely poisonous. It will kill dogs. A lot of people don't realize that the seeds are toxic. But also ginkgos. And ginkgos, there's one species of ginkgo that's still around. It has been around since the age of the dinosaurs. It's got a very, very distinct leaf. You can just type in, I think it was email. I will show you an image of that here in a bit. I used to have one as a kid in my front yard. Very, very distinct pattern on the leaf itself. With Laurasia, we still have conifers. The big difference is that fern that replaced Glossopteris with Laurasia. It was evident with the southern continent, but not the northern continent. Continent. I can speak easily. It still had cycads, things like the sago palm. Still had ginkgos. Still had ferns. There's not going to go backwards. I do not have the right page up here. Look at the section of note. Putting stuff out before I'm ready for it. The picture down there on the bottom is a sago palm. It's not saga. It's not like Sonic the Hedgehog. Sago palm. That particular plant has been around for forever. Like I said, my neighbors got two of them in the front yard. I should have taken a picture of them. I don't know if they're going to live with that freeze we came through. They're both completely and totally brown right now. Cycads had, it's really similar to what you think of as a palm tree, but they weren't palm trees. Palm trees are way, way, way newer than a cycad. This was one of the plants that helped create a shaded undergrowth for organisms to be able to recover. The gymnosperms, things like ginkgos, those were the other plants that allowed that to happen. When you had the movement from the Triassic to the Cretaceous, these particular plants, most of them, obviously not all of them, we wouldn't have the sago palm, most of them were replaced by conifers. And all a conifer is just think of something like a Christmas tree. Something that has a cone that has seeds. Now, eventually, in the Cretaceous, and we'll get to this in a bit, we had flowering plants. But at this point, earlier on in the Mesozoic, there were no flowering plants. Flowering plants were triggered by insects. Just like with the Permian, with the seed coat, insects helped force plants to evolve and to adapt to predation in some way, shape, or form. In the case of a flowering plant, it helped pollinate them. And we saw the rise of flies and bees with the Cretaceous. And they have not changed much. They've just gotten smaller. That's all. Most of the insects haven't changed much. But if you do have a sago palm, just for your information, in your front yard, or like me, your neighbor's front yard, the seeds, if your dog eats them and it's a little dog, it's going to kill it. They're toxic. 100% of the plant is toxic. The same thing as the ginkgo. They're 100% toxic. So just information. These sago palms are, I don't like them. I had one torn out from our previous house. They're nasty. Nasty, nasty plants. They've been around forever. That is not animated right. All right, so Ginkgos, this particular plant has almost like a fan shape. There's a very obvious divide in between the two parts of said fan. I don't ever remember even trying to get the fruit off of one of these, but apparently, I mean, it's toxic, but apparently if you try to pull the fruit off of the nut, which the nut would be the seed, it smells like a combination of vomit and dog crap. Like, it's bad, 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 bad. You're supposed to be able to eat the nut in small quantities, I guess, sort of like the fugo fish, where it's toxic, but just a little bit won't kill you. I wouldn't recommend it. But we do have one species of ginkgo that has survived and made it through, literally from the time of the dinosaurs. I don't understand how either plant made it through the Cretaceous extinction, which we will be doing in a week, next Monday. The whole earth burned. It burned, and then it had nuclear winter, and somehow, some way, both the ginkgo and the sago palm made their way through. Horsetails. I didn't put a picture up here. I should have, but I didn't. These are sort of an aquatic plant with a horsetail. The dinosaurs would be able to come in and chomp down on them and eat the top part, and then they would just regrow extremely quickly. This was a huge source of nutrition for all of the herbivores throughout the Mesozoic. I should have put a picture up here. If you've ever seen a cattail, that's a type of horsetail. It's just a more advanced version of it. When eventually they finally bust open, and it's almost like a dandelion fluff on steroids, where the seeds get pushed through. These are still an early type of plant. They are wind driven. They are not pollination driven like the angiosperms. But like I said, they're a huge source of nutrition for all the different types of herbivores that we're going to start talking about starting Wednesday. I think it's going to be Friday. There is one dinosaur that we know the noise of because we've taken a MRI scan of the skull and we've created a replica, and then we've blown air through it, and we know at least what it could have made as far as sound is concerned. And I'm almost positive that's supposed to be now on Friday, which is the asynchronous day. The Parasaurolophus had a huge crest that went over the top of its head. It's just a giant resonating chamber. For those of you that have been in band, you know what I'm talking about. In blowing air through the replica of what we have from an extremely well-preserved skull, we actually know sounds that that particular organism could have made. Okay, the Triassic, the Jurassic, originally they were seed vests. We changed from spores to seeds because of insect adaptation. Eventually, in the Cretaceous, so we're at the end of the Mesozoic right now, in the Cretaceous, insects allowed for pollination. Bees are unbelievably important, and they developed in the Cretaceous. I'm pretty sure I changed the scientific name to the more modern name on a couple slides from now. You don't know what Neuropteras are. You don't know even all the scientific terms of these. But the most important adaptation for life on this planet of the Mesozoic was the development of a flowering plant, which is called an angiosperm. Now, we're not going to go super in depth. We're not going to talk about the difference between dicots and monocots. You should have done all of that stuff in biology. But this huge difference changed pollination from being dependent on wind to being dependent on insects, specifically bees. We are very much in the midst of a sixth extinction event with the fact that our insects are disappearing at an alarming rate. It's one of the last things that we'll talk about today. I think they're open right there still. So somebody else decides to have sex in the bathroom, they're open right now. Yeah. I don't know if it was that one or not, but yes, that's why they were shut down. I don't know if it was boys, girls, both. I don't know. I just know that that's what happened. I don't know. When I was in high school, we had a brazen couple decide to have sex in the front of the school at the flagpole. I can see their faces, but I can't remember their names for the life of me. And I know I don't have my old high school, what's it called? Yearbook. Thank you. Yes. I'm pretty sure my mom finally got rid of those after 20-something plus years. So like I said, the single most important evolutionary adaptation in the Mesozoic was that of the flowering plant, which is called an angiosperm. They didn't completely push the gymnosperms out, or we wouldn't have things like the sago palm, the cycad, I think this is the palm tree, and the ginkgo, the thing that has the weird, like, vomit smelling fruit. Now I really want to find a ginkgo to see if that's really what it smells like. That's what it said so on the internet. It smells like a mixture of vomit and dog poop. But flowers have a combination of both color and scent to attract whatever it is. Now, there's other pollinators besides the bee, but the bee was the big thing that developed. We're about to switch over to insects here in a second. One of the most major things that developed in the Mesozoic. We have other pollinators like hummingbirds and butterflies. A lot of the insects see differently than we do. They don't see 100% in the visible spectrum. They also see in ultraviolet. And so a flower that looks white to us might look hot pink to them. It just depends. It depends on which specific receptors they have. Most insects that, like the monarch butterfly, that is attracted to things like, not ragweed, brain fart. The specific plant that the monarch lays its eggs on fluoresces to them in a specific color. Milkweed, thank you. Yeah, ragweed is that's the thing I'm allergic to. Milkweed, which can, for us, be different colors. It can be yellow, they can be red, but for them, it's completely and totally different, and they hone in on that particular coloration. Let's see. Oh, there is one more right here. The other thing, flowering plants make fruits. Okay, animals eat the fruit. At the same time, they eat the seed, the nuts that's inside, and as they walk around, they have to poop. And they spread plants' offspring in this particular way. So this particular adaptation which we just take advantage of. Things like apples, strawberries, those are angiosperms. Birds specifically are a huge distributor of seeds. We'll eventually get to birds. We're going to talk about them tomorrow. Birds, mammals, and lesser reptiles, non-dinosaurian reptiles is what we're going to talk about tomorrow. Tomorrow is really lengthy too. We're getting pretty close to being done with today. Insects and plants force each other's evolutionary adaptations. We've now seen this repeatedly with evolution. No, there's not. There are so many different things that force evolution, but your predator prey, and in this case with insects and plants, it is predator prey. It drives evolution at an accelerated rate. If the plants can't compensate for the things that are feeding on them, hence said insects, they go extinct. And I know plants can't think like us, at least not like on the level that we can, but they don't want to die out. And their response to not wanting to die out is to adapt, is to evolve. And like I've said before, your average species lifespan, give or take, is about 3 million years. Most do not last more than that, and hominids have been here for about 2. If we don't change the way that we're putting our carbon footprint out there, we're going to force, we already are forcing the next extinction. Not saying bad humans, evil bad, but we're killing things off at an accelerated rate. All right, so the Permian extinction, we're switching out to insects. Everything we've done so far has been plants. Neuroptera, that's your praying mantis and your like walking sticks, those types of bugs. Mecoptera are your scorpion flies. I didn't put that up here. They literally look like they have a scorpion's tail. No, they don't sting. They just look like they have that. But the tail, the stinger-looking tail is a reproductive thing. But no, they don't sting us like a scorpion. Flies are Diptera, beetles, Coleoptera. I definitely have to stop and read these out because I am not a Latin person. I've just taken medical terminology and I understand at least how the letters are supposed to be pronounced with Latin. You had, once again, radiation does not mean that it glows in the dark. It just means it makes new offspring, different species as time goes on. By the time the Cretaceous was done, most of our insects, except for the fact they were bigger because there was more oxygen and it was warmer, most of our insects were exactly the same that they are now. It's just that now they tend to be a little bit smaller. Or you know, that could be for lies. Lies. Like I said, the major difference between insects from the Mesozoic versus insects from modern times was just sheer size. And we're about to talk about spiders. I like spiders. Spiders, particularly the things that you think of like a tarantula, they're ambush hunters. things that don't catch with webs, they actually catch by jumping on and then like biting them. They were extremely dominant at this time period. But the spinning organism, spinning organ, I'm sure it has a term, but I don't know what it's called. The thing that actually makes a web, that developed at this time period. You had your ones that would spin a web and they would wait and they would shove the web down on top of whatever their prey was and trap it as just an ambush technique. All of this stuff developed at this time. It sounded like a Google noise. No, maybe that was an email noise. That was an email noise. Okay, sorry. I'm trying to flip-flop back and forth here. The multiple eyes of spiders, all of this stuff developed at the same time. The fact that they pretty much can see 360 degrees around them. The compound eyes of flies, they've got hundreds of eyes in some particular species. They can see every which way all at the same time. All right, so bees, flies, wasps, walking sticks, all of these things developed at this time. We still have them today. A lot of them had very brilliant metallic coloration. We know this specifically, like their color, because of specimens that like flew into tree sap and got stuck, and then that fossilized into amber. And just take away the amber coloration, and we know exactly what they look like. We've got trapped flies, bees, spiders, all different kinds of stuff. And one of the things that, one too many. One of the things that you guys asked me when I asked for the writing prompt was, how do we know what color they are? Specifically, things that are trapped in amber, we do know. Just remove the amber coloration, and that's what color it was. I haven't gone too far into looking to see if what else has been trapped besides insects, if there's been any kind of lizards, small lizards that were trapped. I've had the ability to purchase these types of specimens, and I never have because they're expensive. But I need to look further into specifically lizard coloration, because that was one of the questions that I had with that writing prompt. How do we know what color they are? Honestly, we base them off of current organisms. But for the insects, we know for sure. All right, so you have a constant force of evolutionary adaptation between insects and plants. Like I said, your modern insects were completely and totally established by the time the Cretaceous occurred. It was before the asteroids slammed into the Yucatan Peninsula and wiped out a whole bunch of stuff. Without insects, we wouldn't have had the adaptation of flowers, which eventually creates fruit. Without bees, specifically bees, we're in extreme danger for certain species of said flowering plants, primarily coffee. Without bees, we don't have coffee. They don't pollinate any other way, unless somebody specifically goes and does it themselves. which I've had to do before with squash and with zucchini, same thing. Squash, zucchini, same thing. They don't pollinate themselves. I mean, they have both male and female reproductive parts within the petals of the flower itself, but it has to get from point A to point B. I have no idea how well your biology teachers taught you anything about plant reproduction. I just assume that you guys know nothing. All right, so bees. The whole 6 weeks is essentially human impact on our planet. Obviously, you know, we don't want to just roll over and die, but what we are doing to our ecosystem is having a direct effect specifically on the bee population. Just a couple of years ago, we lost over 40% of all of the honeybees in our country. I know my neighbor went and got a couple of bee boxes. And then, of course, his grandson, after watching the bee movie, thought that all bees were friendly and tried to get into it and had to be taken to the hospital because he was stung so many times. But bees are our primary pollinator. This particular extinction of the bees and of the bats, for that matter, bats too, but bats are fungal. Bees are not fungal. Bees are habitat pesticide. There's a good chance that we're doing irreversible harm to our food supply. Not necessarily intentionally, not like we want to do it, but it's a side effect of the things that we are doing to our environment. One more. This is the whole 6th mass extinction. And like I said, it's not just bees. But bees and bats are, and I need to put bats on here. I need to think to put bats on here. They are primary pollinators of our crops. And our only other option would be to literally go to the plant and move the pollen from the anther to the pistil. Like that is literally our only other option in order to pollinate the plants. And like I said, I'm not trying to be all evil bad human, but it's basically evil bad human. Between the pesticides, the habitat destruction, I know that our country is a little bit more conscious of what is going on. But some of the other countries honestly just don't care. And if you ever go visit Japan, all of that smog and all of that crud that's in the air is not from Japan. Japan is not like that. It's coming from China. So, huh? You want to go grab some breakfast? Okay, yes, you can go grab some breakfast. Let me pause this. Stop the recording.